Electron. Electron is a particle or wave? To clarify this doubt, there is a theory, that is de Broglie's wave theory. De Broglie's wave theory explains the dual nature of the electron. It explains both particle nature and also wave nature of the electron. And see here, in the de Broglie's wave theory, the de Broglie, he took mass energy relation given by Einstein and also the relation between energy and frequency given by Mr. Max Planck in his Planck's quantum theory. And see here, we will check this one. What is the Einstein mass energy relation? E is equal to mc square. And what is the relation between energy and frequency given by Max Planck in his Planck's quantum theory? That is, E is equal to h nu. See here, E is equal to mc square, E is equal to h nu. To explain both particle nature and wave nature of electron, de Broglie, he equated both the equations. See here, mc square is equal to h nu, and we know that nu is equal to c by lambda. One of the c and this c will get cancelled with each other. What is c here? C is nothing but velocity of light in vacuum, and m is mass of electron, h is Planck's constant, and lambda is wavelength. See here, therefore mc is equal to h by lambda. We can write in terms of wavelength, that is lambda is equal to h by mc. Here c is nothing but velocity of light in vacuum, it is nothing but velocity, that's why we can write it as h by mv. And we know that the product of mass and velocity is nothing but momentum. Therefore, we can write here mv as momentum, that is equal to h by p. Now, finally, the de Broglie's wave equation is lambda is equal to h by p. h by p. Wavelength is equal to Planck's constant by momentum of the electron. Here, the de Broglie's wave equation explains the dual nature of the electron. Now we will calculate a few problems to understand more about de Broglie's wave equation. Let us start the problems. And let us start few numericals. And first one is, the momentum of a particle of wavelength 1 angstrom is, they given wavelength as 1 angstrom and they gave momentum here, and see here, in all the options they gave momentum in CGS system. This is one of the important point. We have to observe the units also. What is the relation here? According to de Broglie, lambda is equal to h by p. Here, wavelength is equal to Planck's constant divided by momentum. They are asking to calculate momentum, that's why I am changing this one as p is equal to h by lambda, means Planck's constant by wavelength. See here, Planck's constant in CGS system. Why I am taking in CGS system? Because the answer is in CGS system. The given answer is in CGS system, that's why we have to take this one in CGS. Planck's constant in CGS system 6.625 into 10 to the power of minus 27 erg second by, here they gave wavelength in angstroms. 1 angstrom is equal to 10 to the power of minus 8 centimeter. 10 to the power of minus 8 centimeter. See here, if this 10 to the power of minus 8 moves up, then it becomes 10 to the power of plus 8. Then it is equal to 6.625 into 10 to the power of minus 27 and 10 to the power of 8 in the sense 27 minus 8, what is that? Minus 19. centimeter per second. What is the answer here? The second one is answer. 6.625 into 10 to the power of minus 19 gram per second. And please check this one, and we will do one more. Check the next one. The de Broglie wavelength of a particle with mass 1 gram and velocity 100 meter per second is. Here they gave mass 1 gram and velocity 100 meter per second. See here, what is the wavelength equation here? Lambda is equal to h by mv. h by mv. Here they given answer in meters, means in SI units. That's why we will take h value in SI units. What is the value of Planck's constant in SI system? 6.625 into 10 to the power of minus 34 joule second divided by, what is the mass here? They given mass as 1 gram, but here we have to convert grams into kilograms. 1 gram is equal to 10 to the power of minus 3 kilograms into, what is the velocity given? 100. See here we can write 100 as 10 square meter per second. See here, if you simplify these two things, we will get 6.625 into 10 to the power of minus 34, 10 to the power of minus 3, 10 to the power of 2. If we simplify these two things, we will get 10 to the power of minus 1. And see here, if 10 to the power of minus 1 moves up, it becomes 10 to the power of 1. And 10 to the power of minus 34 and 10 to the power of 1, it is equal to 10 to the power of minus 33. I will write here to show clear step. 6.625 into 10 to the power of minus 34 into 10 to the power of 1. Then it is equal to 6.625 into 10 to the power of minus 33 meters. Let us check the options. Here 6.63 means they took this part as 6.63 because after 2 it is 5 or 5 is there. If 5 or more than 5, we can round it to next number. That's why it is 6.63 into 10 to the power of minus 33 meters. Then first option is correct one. Please note down this one and we will do one more calculation. Next one, if the wavelength of the electron is numerically equal to the distance travelled by it in 1 second, then what is the wavelength here? They gave different relations here. Here they gave one point, that is wavelength of the electron is numerically equal to distance travelled by it in 1 second. Distance travelled by in time in the sense that is velocity. Means indirectly they are telling wavelength lambda is equal to distance travelled by it in 1 second in the sense it is equal to its velocity. What is de Broglie's equation? Lambda is equal to h by mv. Here lambda is equal to v. Lambda is equal to v. That means we can take it as lambda is equal to lambda, because lambda is equal to v in the sense lambda is equal to lambda. We can write, see here, lambda into v is equal to h by m. Here lambda is equal to v in the sense we can take it as lambda, we can write it as lambda square, that is equal to h by m. Therefore lambda is equal to root of h by m. Finally lambda is equal to root of h by m. What is the relation here? Once you check these things, lambda is equal to h by p square, lambda is equal to root of h by m. Nothing but our answer. Second one is the correct answer. Once again check it. They given one condition, wavelength is equal to distance travelled by in 1 second, means lambda is equal to velocity. What is the de Broglie's equation? Wavelength is equal to h by mv. Now if we take v to another side, lambda v Lambda b in the sense lambda into lambda, lambda square, that is equal to h by m. Therefore, lambda is equal to root of h by m. This is the relation between lambda and Planck's constant and mass of electron when wavelength is equal to velocity of the electron. Please note down this one. Now we have an interesting relation here. See here, a hydrogen molecule and helium atom. Check this one. Hydrogen molecule, helium atom. That is molecule, this is atom. Don't forget that one. A hydrogen molecule and helium atom are moving with the same velocity. One more condition. Moving with same velocity. Then the ratio of their de Broglie's wavelength is de Broglie's wavelength. See here, what is the de Broglie wavelength? Lambda is equal to h by m. They are asking ratio of their de Broglie wavelength. Ratio of their de Broglie wavelength. See here, if you consider this one as, this is for hydrogen molecule H2. Then Planck's constant is constant, and here m is mass of hydrogen molecule. I am taking it as mH2, and v is velocity of hydrogen molecule vH2. Divided by wavelength of helium atom, that is equal to h by mass of helium into velocity of helium. See here one condition is there, they are moving with the same velocity. That's why we can strike out velocity. Next one, Planck's constant is common for both the things. We can strike out Planck's constant also. Therefore, that is equal to 1 by mH2 means mass of hydrogen by 1 by mass of helium atom. A by B divided by C by D in the sense A by B into D by C. Mathematical basic. To calculate all these things, we have to learn mathematical basics. Then only we can do calculations easily. Okay. See here, therefore, wavelength of hydrogen molecule divided by wavelength of helium is equal to, what is that? Mass of helium atom by mass of hydrogen molecule. What is the mass of helium? It is 4. Mass of hydrogen molecule 2. 2 ones, 2 2s, that is equal to 2 by 1. We can write it as 2:1. What is the ratio of de Broglie's wavelength of hydrogen molecule and helium atom? That is 2:1. What is the answer here? 2:1. This is the answer. Sometimes instead of hydrogen molecule, they will give hydrogen atom. Hydrogen molecule mass is 2. Hydrogen atom is 1. Then it is 4 by 1. We will get 4:1. Don't forget that one. When they are giving hydrogen molecule, take mass as 2 because H2. If they given it as hydrogen atom, you consider it as 1 because mass of hydrogen atom is 1. Then if it is hydrogen atom, we will get 4:1. If it is hydrogen molecule, we will get 2:1. That is the difference. Okay. Please note down this one. In the next calculation, they are asking the wavelength associated with a golf ball weighing 200 milligrams and moving at a speed of 5 meters per hour is of the order. They gave options as 10 to the power of -10 meters, 10 to the power of -20 meters, 10 to the power of -27 meters, 10 to the power of -40 meters. What they are asking? They are asking wavelength. Wavelength lambda is equal to h by mv. h by mv. See here the given answer in meters means they calculated in SI system. What is the value of Planck's constant in SI system? 6.625 into 10 to the power of minus 34 joule second by mass of the golf ball is 200 milligrams, but we have to convert that one into kilograms. 1 milligram is equal to 10 to the power of minus 6 kilograms. You have to learn all these conversions, then only we can calculate it easily. 200 into 10 to the power of minus 6 kg, and velocity they given 5 meter per hour. We have to calculate in terms of 5 meters per second because the SI unit of velocity is meter per second. They given per hour. Per hour in the sense 1 hour is equal to 3600 seconds. 3600 seconds. Here we can write it as 5 by 3600. You can write this one as, you can shift this one to here, 3600 seconds. See here, let us simplify this one. That is equal to these two zeros, then it becomes 10 to the power of minus 4, and 2 5s are 10, 2 5s are 10, and here we will cancel 1 0 here. 2 5s are 10, get cancels one of the 0 here, means 3600 by 10 is equal to 360. Now see here, if you multiply 360 with 6.6, then here we will get 2160. Then if you add these things, you will get 2376. 2376 into 10 to the power of minus 34, and in denominator we have 10 to the power of minus 4. It will move up and it becomes 10 to the power of 4. That is equal to 2376 into 10 to the power of minus 30. And see here, in the given options there is no 10 to the power of minus 30. Then we can write it as 2.376 into 10 to the power of minus 27 meters. They are asking is of the order. We got this one, that is 10 to the power of minus 27 meters. Then option C is correct answer. Complete answer is 2.376 into 10 to the power of minus 27 meters. They are asking only 10 powers, that's why option C is the correct answer. If they given complete answer, the complete answer is 2.376 into 10 to the power of minus 27 meters. Please note down this one. It is a special case in de Broglie's wavelength. Till now we calculated wavelength, momentum, mass, velocity, different things related with each other. In this case, they gave temperature also. There is a relation between temperature and wavelength with respect to de Broglie's wave equation. See here, the relation between wavelength and the temperature is lambda is equal to h by root of 3 mkt. See here, h is nothing but Planck's constant and m is mass of the electron or mass of the particular particle, and k is Boltzmann constant and T is Kelvin temperature. What is k here? Boltzmann constant. What is the value of Boltzmann constant? Boltzmann constant value is equal to 1.38 into 10 to the power of minus 23 joule per Kelvin. See, the atomic mass of helium and neon are 4 and 20 AMU, atomic mass units, 4 and 20. The value of de Broglie wavelength of helium gas at minus 73 degrees Celsius is how many times? how many times that of the de Broglie wavelength of neon at 727 degrees Celsius. See here we can write it as wavelength of helium is equal to h by root of 3, mass of helium is 4. I am writing k value as k itself because we are going to cancel, because we are going to find out the ratio. That's why I am not substituting the value, because we are going to cancel that one. And Kelvin temperature. Temperature of helium gas is minus 73 degrees Celsius. After converting into Kelvin temperature, minus 73 plus 273 is equal to 200 Kelvin. That is equal to 200 Kelvin by wavelength of neon, that is equal to h by root of 3, and mass of the neon is 20 into K. And what is the temperature of neon? 727 degrees Celsius. 727 degrees Celsius in the sense Kelvin temperature is 727 plus 273, that is 1000 Kelvin. 1000 Kelvin. H cancel, 3 cancel, K cancel, 4 ones, 4 fives, 200 ones, 200 fives. Therefore, wavelength of helium by wavelength of neon is equal to, after simplifying this one, we will get 5 5s are 25, root 25. Root 25 is equal to 5. Means wavelength of helium is 5 times greater than wavelength of neon at this particular temperatures. Hope you understood this one. See here, this is one of the important equation. Lambda is equal to h by root 3 mkt. Here k is Boltzmann constant, and you learn this value also. Here it's okay, but in general we have to substitute the values. Here we are going to cancel, that's why I written k as k here. And these are all important calculations for JEE mains and advanced. That's why you keep on practicing all these things. It will come under numerical section. And don't forget to like it and share it with your friends, and ask your friends to subscribe our channel Mr. Chemistry. Okay, and see you in next class. And today we discussed a very good concept, that is de Broglie's wave equation, which explained the dual nature of the electron, one of the important concepts from atomic structure. Thank you.